Greetings and welcome to the United States Transhumanist Party Virtual Enlightenment Salon. My name is Gennady Stoliarov II, and I am the chairman of the U.S. Transhumanist Party. Here we hold conversations with some of the world's leading thinkers in longevity, science, technology, philosophy, and politics. Like the philosophers of the Age of Enlightenment, we aim to connect every field of human endeavor and arrive at new insights to achieve longer lives, greater rationality, and the progress of our civilization. Greetings and welcome to our Virtual Enlightenment Salon of April 24th, 2022. We have a fascinating discussion in store for you today about how emerging technologies and personalized medicine are helping patients with rare diseases both diagnose and treat their conditions, as well as hopefully cure their conditions in the not too distant future. Joining us is our distinguished panel of U.S. Transhumanist Party officers, including our Director of Visual Art, Art Ramon Garcia, our Vice Chairman, Arin Vahanian, and our Director of Longevity Outreach, Ben Ballweg. Our special guest today is John Marlowe. John has been a longtime member and friend and ally of the longevity community. He is an advocate for research on rare diseases, for regenerative medicine and rejuvenation biotechnology, which focuses on biological age reversal. And he is also the co-founder of PathoGene Incorporated. He is going to discuss today how emerging technologies and personalized medicine are helping patients like never before. And John has quite a story himself as to how he became involved in this field and how a variety of technologies and approaches have helped him personally. So welcome, John. It's an honor to have you today, and you have the floor.
Thank you very much, Gennady. It's really humbling to be here. I watch these and they're very entertaining. So I'm able to provide some value to those that are listening. So a little bit about me and my story as far as rare diseases go. It's a genetic condition, and I was born with it. And I was always very skinny. I had appetite problems, and eventually I started vomiting when I was in my 20s. But I always had problems putting on muscle. It was just I was very weak and frail, and it's just a problem my entire life, and it got progressively worse as I aged. So in my 20s, when I was at Berkeley, I was while I was attending film school, on my spare time I'd be going to the California Pacific Medical Center, which was focusing on motility. At the time, I had no idea it was a genetic condition. No one knew what it was. I mean, the diagnostic odyssey for rare disease patients, as I think many rare disease patients know, is 10 plus years. Anyway, I was going there, and I became really kind of well versed on receptors and this and that, and they prescribed me nortriptyline, but I ended up taking mirtazapine because I found it had very potent antiemetic properties, and that's really what got me through Berkeley. Is just doing my own research on things that would stop my vomiting as a result of my genetic condition, which I later found out what it was. I could go through. Maybe I can make that a separate question, Gennady, of some of the things that I've tried. But long story short, I ended up, on a long road of differential diagnosis, basically trying this, trying that, trying this, trying that, slowly making improvements, but not exactly knowing why it worked. And then eventually I got my exome and then my genome sequenced with Illumina technology, and they actually had misdiagnosed me with hereditary fructose intolerance, and I had to go off fructose as someone who's already quite thin, that was really torturous, and it wasn't the diagnosis. So I had read after that in exasperation. I was doing some research, and I found Ewan Ashley's paper for long read sequencing used for the first time in a patient, or clinical long read sequencing, something to that effect. Ewan Ashley's the associate dean at Stanford, and he's got his own lab. He's a real pioneer in genomics. Anyway, I read his paper and I said, you know what I need? I need either PacBio, Pacific Biosciences genome, or an Oxford Nanopore genome, because in that study, what they found is that this patient who had cardiac tumors, in this gene that's usually they suspected this involvement of this one gene, but they couldn't find the genetic defect with Illumina technology. So they sequenced him with Pacific Biosciences, genome sequencing technology, their single molecule real-time sequencing, and they found it in that same gene, and it couldn't be resolved with the second generation technology. And so ultimately, that's what I asked for. And I asked my friend, who later became one of my best friends, Pete Kane, who runs Research to the People. At the time, it was Silicon Valley Artificial Intelligence. And they asked me, what do you want more than anything? And so I said a PacBio genome. And I got the Oxford Nanopore genome from Dante Labs. I encouraged them to really move into the future, and they generously provided that. And so anyway, long story short, in 2019, there was a hackathon called Undiagnosed 1. And you can look that up if you're curious. It's Undiagnosed 1 post-event trailer. If you type in that, you'll find it in YouTube. But 200 people came from around the world to look at my Oxford Nanopore genome, PacBio genome, various Illumina genomes, lifetime medical records, everything. They used AI, bioinformatics, everything. They threw everything in the kitchen sink at it, and it was all Stanford PhDs, Berkeley PhDs, MDs, people from India, Japan. It was crazy. 200 people for 3 days. And one of the teams, Team Tenacity, which is they were naming themselves after Tennyson X, which is ultimately the gene that's involved in my disease. It's a pun, and tenacity. They found the frameshift mutation in TNXB, which basically causes a rare form of Ehlers-Danlos syndrome, which explains my my muscle issues. It's essential in connective tissue and gastrointestinal stomach lining, so that's why I got stomach aches and I threw up all the time. It's involved in just a lot of different things, and pretty much everything that I had problem with, Tennyson X had a role in. And so it's pretty much a definitive diagnosis, but it has to be yet to be validated. But unfortunately, long read sequencing still hasn't been rolled out clinically. It's still in the domain of research, even after all this time. But it's about to be rolled out, thanks again to Ewan Ashley, the guy I mentioned earlier, who is really pioneering this. And he recently was able to get a human genome down to 5 hours, sequencing 5 hours and diagnosis in 2 hours. And he did a bunch of patients actually, and I think the average with sequencing and diagnosis was between 8 and 10 hours. So it's going to be rolled out pretty soon. And just before I go to questions, I'd just like to point out that the way that short read sequencing works, in case anyone's curious, that's what you get now with an Illumina genome or Dante Labs or Nebula Genomics or sequencing.com. It's a variation of Illumina, one of the Chinese sequencers, or is very similar to the way that Illumina works. They're called short read sequencing. And so what it is it takes your genome, 3.2 billion base pairs, and it confettis it up into smaller pieces, right, to 100 to 150 base pairs long. And if you can imagine, like when you're a child and they said count to 1 to a billion, you can't do it, right? And that's kind of like the same concept with sequencing. It's like going from one side to the other of 3 point. So it takes too long, so they chop it up into small pieces, parallel, make it all in parallel, and then stitch it up later, right? And that's kind of like how it works. But the problem is that there are repetitive areas of the genome, and that's where my gene of interest is in a very repetitive area. And what happens is that if you have a bunch of identical segments in a repetitive area, it doesn't know if there are redundancies. It doesn't, because it doesn't know how many redundancies should go in there, because there's no real. It's just you get data loss. They're called sequence gaps, and so my diagnosis was in a sequence gap, and so long read, it takes base pairs of anywhere between 10,000 and over 1 million. And that's how long the segments are. And so they're much more distinct, and so they're able to reassemble the genome with greater contiguity. And that's what made a difference for me clinically, and it's what's making a difference for a lot of people now. And that's the technology that actually in 2021 was used to fully assemble, and this year too, actually, it's kind of an ongoing thing, but fully assemble a human genome, gaplessly, end to end. And now the NIH and NHGRI are working on scaling that so that we have, contiguous genomes for more people, more reference genomes, more things of that nature. Anyway, that's kind of like my story in a nutshell.
Yes, thank you, John, for sharing your story. And I think a lot of fascinating questions can be posed to inquire further about some of the opportunities that you've had, as well as opportunities that other patients might have to diagnose and overcome their rare disease conditions. First, I would like to thank Celeste Castaldo for her generous super chat. She says she's in the middle of setting up a new office in San Diego, but she will be able to join us live again in a few weeks. She says, thanks for the great speakers and panelists at the salon. Well, thank you, Celeste, for being such a generous and loyal supporter of this venue where we can bring these kinds of unique and fascinating conversations to the wider world. So, John, I wanted to ask you about this trial that you've recently participated in for the use of bicarbonate to overcome back pain. How does it work, and what effects has it had on you?
So thus far, the effects have been just my mood has completely changed. The pain is completely gone, and it is just absolutely amazing. So it's a kind of the first in human, at least that I know of, um, trial of kind of using bicarbonate not just to help with stem cell proliferation, but also to alleviate back pain itself. So as many of you may or may not know. As discs degenerate, they get more and more acidic, right? So the extracellular matrix, the cushion of the disc breaks down, and it breaks down to lactic acid, and then that acid, breaks down more ACM, and then that's basically a cascade, right? And the lactic acid is actually, it's been demonstrated in many studies to be a biomarker for back pain. And in fact, I just found a study where they did it was very obscure. I sent it to my physician, but they did it on animals where they were able to kind of change the pH in all areas of the disc, and it immediately was able to alleviate back pain in a lot of these animals that they were testing on. Um, and so that was kind of the case with me. There's actually a video of me on Instagram after getting the bicarbonate injections. Just not even the stem cells yet, but the bicarbonate just to alleviate pain itself. And I was just gasping in relief. I wasn't acting. People thought I was acting, but it was like it's like a lactic acid burn sensation inside the disc when you have degenerative disc disease. It's just a constant kind of ache and a burn, and it can get into your sciatic nerves and kind of burn there. And I just felt that even with other prior stem cell injections, it was just burning and burning. And then so I proposed this with Dr. Shonak Patel, who's one of the top 5 regenerative medicine specialists in the country. I proposed that we try this. And after a lot of research into how much to put in there, because of course the question is how much do you put in there? How do you measure how much you're putting in there? It's very complicated. It sounds simple, just put some bicarbonate in there, but you don't want to change the pH to a point where you could hurt yourself, right? Where you might, there were concerns about possible infections. So we were looking into the microbiome of the disc, right? And what pathogenic bacteria are in there, like P. acnes, and what range of pH they thrive in. So there's a lot of this research that we both did on this, and eventually, when I was on the table, what he had told, what he had planned was to bathe the inside of the disc for about 2 minutes before the stem cells go in. And the reason for that is, I sent him some tissue engineering journal that said that the microenvironment of the disc had to be optimized for regenerative medicine in order for cells to proliferate. And indeed, that's very true. In vitro, when they were looking at mesenchymal stem cells, which are the cells they use for, orthopedic regenerative purposes, they tend to proliferate in slightly basic environments. So like 7.1 to 7.4, if I recall correctly. So, and then the disc can be, it's 6.8 and it goes further more and much more acidic. It can go pretty dang low, like 5.8, from what I've heard. So it's not good for them. And and acidity, the acidity scale is logarithmic, so it's significantly more acidic, as it goes down. Anyway, when he put that acid in there, I was just gasping, and then he put the stem cells in, and it's been about 5 days, and I got to say, like, my outlook on life just is so much better, and I'm just hoping that it's not a transient, I'm hoping that it's durable at least for a year, or two, because this is just profound. It's what I've been waiting for so long.
Yes, thank you, John. And I do hope that the effects last for you. I have linked to John's Instagram account for anybody who wants to follow him on Instagram and also view the videos of his procedure as well as his other posts, because John details extensively his diagnostic odyssey as well as a lot of his thoughts on advocacy for rare disease patients. Now, our friend Daniel Twett states that bicarbonate is certainly a low-cost therapeutic DIY agent. I wonder, do you think this kind of procedure, if it were refined and developed for mass deployment for patients, could be a relatively inexpensive type of treatment for degenerative disc disease or other kinds of back pain causing issues?
Yes. So I'm waiting to see how long it lasts, but if it does indeed work, then what could be done? I don't think it could be DIY, because putting a needle into the intervertebral disc is, a very delicate thing. You really want to make sure that the hole is as small as possible. So something your orthopedist would probably do, orthopedic surgeon, but it would be a very quick procedure. And what they would do is probably take an antibiotic like gentamicin, which is what it was used on me, because again, the disc has a microbiome, and you don't want to introduce anything or disrupt. You don't. It's a good prophylactic to put a little bit of gentamicin in there, and then put a bit of bicarbonate in there. I could probably ask my physician. We could probably standardize it. The protocols, but I do think that this would be an amazing interim therapy until we were able to figure out how to reliably fix the intervertebral disc, which is pretty complicated. It is quite complicated. There's a bunch of products on the market, from like 7 amino acid peptides that, like, apparently they have you know they have effects on, like, transcription, and they're very I haven't really gotten into that, but I think it was like Spine Biopharma is doing something like that. And then there's Discgenics, which is doing disc progenitor cells. Allogeneic disc progenitor cells means like off the shelf, specifically cells that turn into disc cells, NP, nucleus pulposus cells. Then there's Mesoblast, which is about to get approved for FDA approval, which is allogeneic mesenchymal stem cells, which is like donor bone marrow derived stem cells. And then there's biorestorative therapies, which is doing autologous mesenchymal stem cells. So they have a protocol patented for bone marrow extraction and putting into the disc. There's a ton of companies. Dermal fibroblasts from Spinalsight, which takes like skin, and then they're able to somehow harvest the regenerative capacities of that, put that intradiscally for spine, disc regeneration. A lot of promising things are on the market, and getting this pain relief would definitely allow people to be more patient and thoughtful about what they choose to ultimately put in their disc, because there is a lot of scams out there, like, at least what I think are personally scams. Like, there's this one company that was they're advertising fibrin, intradiscal fibrin, to kind of seal the disc. And I had some friends get that, and it kind of made them a little worse. And they were claims that it would fix absolutely everything. And made a mistake too. I went to a stem cell practitioner when I was in abject suffering, I was on the floor. In fact, I was just begging for stem cells, and so I tried something new. I had tried allogeneic stem cells, so donor stem cells from Wharton's jelly, from donor umbilical cords. That's not embryonic stem cells. They're specifically mesenchymal stem cells isolated from the Wharton's jelly. But this guy was saying that they have 5 times the proliferative potential of normal adult cells, and that blah blah blah. And he's going to use exosomes as well. And it's kind of a lot of woo woo talk, And so I ended up getting it. And he during the procedure, he actually put some into my bloodstream, which I'm still not happy about because I don't know. I mean, my doctor said not to worry about it. My new one, he said they're probably all dead, all the cells they injected, which is good. But I just had worries about getting a teratoma, which is what you really don't want. Teratomas are like when they inject like pluripotent stem cells into your bloodstream, and then like a tooth or something will grow in your spine or something like that. You know what I mean? Like something weird. So yeah, I mean, people make desperate decisions when they're in desperate, huge amounts of pain, and so, and there's so many. The cavalry's on the way, but it's going to be a little while. So it would, to answer his question, I do. That's actually something that I really would put. I'm going to push for if this is durable. I don't want to push for it before I know that it would last for a while. But if it does, then I think he's absolutely onto something. Getting, scaling this bicarbonate therapy with antibiotics, especially in third world countries where they wouldn't be able to afford stem cells, just getting a bit of bicarbonate, that might be it might reduce pain on the scale of millions just until there's regenerative options.
Yes, thank you, John. And a lot of our viewers empathize with the situation that you described. Wait What 469 writes, for sure, when you are in enough pain that it prevents sleep or hinders your life significantly enough, it's tempting to look at anything to help. And John H., a fellow John, writes, relentless pain, even at low levels, tends to be demoralizing. He also points out stories like John's make one grateful for just general good health, which is too easy to take for granted. And I think that's the case for a lot of people, unless they have an ailment that leads them to experience a lot of pain or significant deterioration in their quality of life, they may act too dismissively toward just a general state of good health. They don't realize how many things have to go right in order for that to happen. So, thank you, John, for those remarks. Now, I do have a question with regard to the bicarbonate injection. So, from a very simple, basic chemistry type of understanding, bicarbonate is basic. Bases can neutralize acids or essentially increase the pH of the surrounding area. And if the acid is what's causing the pain, then the bicarbonate can alleviate it. My question is, how long, from a theoretical standpoint, could it potentially last? Because I presume if the same underlying problem continues, more acid will be generated and eventually that pH will be lowered again. What have you heard from your doctor about the prospects for that treatment being of an enduring nature?
So right now, again, there's a lot of unknowns. I've heard different things from different physicians, and so ideally, what would be happening is that the bicarbonate would be creating a more hospitable environment for the mesenchymal stem cells that have been injected. And then those mesenchymal stem cells, from my understanding, the mesenchymal stem cells have like a 5% differentiation rate into disc cells. So anyway, maybe there'd be a higher amount of proliferation and a higher amount of nucleus pulposus cells being generated. And those actually have a role in, from my understanding, and I'm not a doctor, but from my understanding from the research that I've done, these nucleus pulposus cells have a role in kind of maintaining the extracellular matrix, which is the cushioning material, as well as kind of buffering the bicarbonate kind of cycling inside the disc. So there actually is a normal bicarbonate kind of cycling mechanism that happens in the disc, and in degenerative disc disease it gets disrupted, and then slowly over many years the acid starts to accumulate, and thankfully, acidity is kind of logarithmic. So it's like, we put in, like, we changed the amount of acid by just, a huge amount by putting that bicarbonate, and there's a much less acid in there. The question is how is that gonna, we really just don't know how fast that's going to last, and if the stem cells are going to proliferate and turn into something that's going to buffer it, and most likely they will. But there's so many unknowns right now. But there is one big accomplishment of this study, in humans. It's that you can get instant relief from injections of bicarbonate, and maintaining that, as well as disc heightening, the acid pH neutralization, is also critical in getting back your quality of life. Because I let me tell you, after he injected, normally I'm like, I've had four intradiscal stem cell injections over many years. I get them once every 2 years. But this is the first time that after a stem cell injection, I was in no pain. I was standing. In fact, I walked a mile the next day, and my mood has improved. I've been talking to all sorts of people, very happy, cheery. I've kind of forgotten at some point that I even ever had back pain. It's so profound. And so I think doctors now can really, they need to focus on that. And I think that with a lot of the therapies that they use, they may start injecting bicarbonate to augment what they're injecting, right? So again, there's just a lot of unknowns, but we did at least figure out that the cause of a lot of people's back pain is that lactic acid burn. It's real.
Yes, thank you, John, for that answer. And it's interesting because it seems, apart from neutralizing the acid, the bicarbonate helps create an environment where the stem cells could ultimately repair the disc and solve the problem. Our friend Mike Lazine comments that with John Marlowe's knowledge, he would think that John is himself a doctor, but really John is a very educated patient who has been learning about the science, the biology related to his condition and related conditions for many years. And John, I'm wondering if you could share your thoughts about how important it is for a patient to educate him or herself about his or her condition and take this proactive role, because I think there are too many patients who just trust whatever a doctor tells them, and they may miss something as a result. Their doctor may miss something as a result. So what can patients do to essentially become like you and educate themselves and become almost as knowledgeable as a medical professional in areas where it really has a personal significance?
Oh, thank you. It's very kind of him to say that. And I guess my advice, and thank you, Kennedy, as well. My advice would be, first of all, make a lot of doctor friends, on Facebook, or just have a lot of people in your doctor network that you can ask for second opinions, right? Get their emails and say, what do you think about this? What do you think about that? If you're thinking about trying things, always get, like, kind of like, use them as a focus group, right? Use your educated PhD friends and everyone as a focus group. You should be adding really smart people on Facebook, people that have really good credentials, because I mean that's like your village, right? I mean, you really have to think about that. And so that would be my first advice, is just really add people with a diverse knowledge set and skill set, and use that opportunity to teach yourself. My second thing that I would really suggest is, before I get into the third thing, which is about the news. The second thing is that really you have to look at yourself, as personalized medicine. The idea of it doesn't just concern rare diseases. It concerns longevity too. If you think about it, all of us have a rare disease. Everyone on the planet, even if it doesn't manifest, in our youth, eventually something, we have a unique genome, right? And so because we have a unique genome, just because it's similar to someone else's, genetically it's distinct. And I'm pushing for that kind of view, that sort of framework. We all have a rare disease. Everyone in the world has a rare disease. So what do we do about that? Well, we push for the best technologies to diagnose us, and that includes like getting a, ultimately what we all want is a telomere to telomere assembly of our genomes, right? That means a gapless assembly so that we can look at absolutely everything, and people can run analysis software on all of it, and we can figure out every little nook and cranny of it. And if you have a telomere to telomere assembly of your genome, you can also look at all the aging biomarkers all the way down, not just methylation, but acetylation as well, which is another, epigenetic marker, which I think is going to gain prominence in the coming years. So you could look at all of it and then get a complete understanding of your health and how you're doing, right? And so to that end, if you have any specific medical problems, the reason that I'm where I am today, the reason that I know as much as I know, the reason that I got that hackathon, the reason I learned about you and Ashley, the reason I know all of this is because I'd go to the Google tab, and that thing with news, that is the most useful thing in the world, right there, the news tab. So you type in degenerative disc disease, regeneration, whatever. If you have Hashimoto's encephalopathy, you type that in, and you type in treatment, you type in DNA, genetics, just be creative with the news tab, because there's a lot of cool studies and news coming out that just goes completely under the radar, and no one sees it. And it's fascinating stuff. And, it could really keep your morale high. If you're dealing with a chronic illness and you think that nothing's being done about it, you use that news tab, you might find that there's a lot more being done about it than you think. So that would be my advice. And the final thing is, I guess, just to emphasize again, get the best testing that you can. So, and know what the best testing is. And I'm happy to answer any questions if people want to know what some of that is. But like an optical genome map, for example, and then a nanopore genome, you can actually combine those to create a more contiguous genome. They actually did that when they finished the genome telomere to telomere. They were actually combining multiple technologies. They were combining PacBio, Oxford Nanopore, Illumina, BioNanogenomics, and then they combined all four of these data sets, and then they kind of like polished them and everything, and that's how they got the telomere to telomere assembly. So just remember that data is crucial, and get the best data, and always make sure that you keep your medical records on a separate hard drive, because that is really important for figuring out your health in the future. That's my advice.
Yes, thank you for that advice, John. I think a lot of people will find it invaluable as they pursue answers regarding their own health, or even just identification of prospective risks that they may face as they become older. Now I would like to turn the conversation over to some of the other panelists for their questions and comments. Let's start with Irene Vahanian.
Thank you, Jen. I really appreciate it. And thank you so much, John, for joining us today. It's a pleasure to have you. And I'm honored to be your friend. And since we met a number of years ago, to when you told me about your journey, I've been really happy to do whatever little I can to support you. And to hear this news today really, really makes me very happy. I have a question. So since we met, I believe it was for the first time in 2018, until now, so it's about 4 years. What's in your mind, is there obviously a lot of things have changed in the last 4 years, probably not as fast as we would have hoped, but what is one medical technology or sort of breakthrough that's happened in the last few years that you're really happy about, or you've got a lot of hope that this will be a real game changer for people who are in a similar situation as you are?
That's a good question, Irene. I have to emphasize again that the biggest, I didn't emphasize how big it was, but I think the biggest breakthrough, and people haven't made, people in the science world made a big splash about it, but it's the complete assembly of a human genome without any gaps, because that is what I've been hoping for more than anything. Because people think that there's such things as junk DNA. No way, DNA is junk. There's nothing in your genome that can be that you need everything to understand your health. Because like these parts of your genome, from my understanding, that are were considered junk are, they have regulatory functions. They control the protein encoding parts, how they behave, right? And so, it's not just good enough to have just the protein encoding parts, but also these were very repetitive regulatory regions. And now scaling that, now that it's possible, because it was impossible before, right? And up until 2021, 2022, just very recently, impossible, couldn't be done, never been done. Now we're trying to make a reference pangenome that's completely telomere to telomere, or T to T as they call it. The telomere to telomere consortium is the one that's working on this. And so they, I think, a genome in a bottle too, I forgot. But anyway, a bunch of brilliant people are working on this. And once that becomes standardized, and I've been saying this for the longest time, but once that becomes standardized, it's not just going to be rare diseases and that explodes, right? That area. It's going to be regenerative medicine, right? Because if let's say you're trying to control stem cell fate, right? Then ultimately you want to have all the epigenetic markers. You want to have a full profile of the cell you're injecting, right? So you want to have a telomere to telomere assembly of that stem cell, so that you can manipulate it, and control exactly what it becomes, so that you optimize the regenerative potential of it, right? So having a telomere assembly means you have a telomere epigenome assembly as well, and then it also will help with aging clocks. So with different tissues, they age at different rates, right? So you could take a bit from your skin, you could take a bit from do a puncture biopsy, I guess, of different parts of your body. I mean, I was talking about that with research to the people, actually doing like a multiple, like a clock, trying to get multiple different tissues from different parts of the body. But you'd be able to do that with greater clarity than ever before. And you'd also have an understanding of what to, if all the diseases you're at risk for, you'd be able to optimize your diet and what medications you take. The level of medical advancement that scaling the telomere to telomere genome would provide we can't even imagine it now. But believe me, that once that is scaled, and once you go to the doctor's office and it's standard to get a telomere to telomere genome, so many things are going to be cured, and the aging will make quantum leaps. So that's my answer. I hope does that answer your question, Noreen?
Absolutely, yes. Thank you for sharing that detail. And just hearing you talk about this makes me excited. I haven't been through the sort of pain you've been through for most of your life, and but just hearing you talk about this, how passionate you are about this, it makes me excited too, to see what's just around the corner in terms of these kinds of developments.
Yes, absolutely. And our friend John H. writes along these lines, junk DNA just means we don't know what that stuff does. So our knowledge about that is expanding. Now, for our audience who may be familiar with the Human Genome Project that essentially concluded around 2003, can you elaborate on the distinction between what that effort achieved and what was achieved a lot more recently in 2022 in terms of sequencing the human genome? What more complete knowledge is available now that was not available 19 years ago?
In 2000, I think it was ended in 2004, and it was run by Dr. Francis Collins, who was actually the director of the NIH up until very recently. I think last year, at the end of last year, he resigned. But he was Dr. Francis Collins sequenced using something called Sanger sequencing. They had sequenced 92% of the genome, and so there was 8% of it missing. That's kind of a lot, and there. It's just there's a lot of people that had genetic diseases in these regions that that were just completely missing. And now with the advances in genome technology, we've gotten the diagnosis rate. From my understanding, the current diagnosis rate has gone up from 30% for whole genome up to 42%. So it was kind of at 30% for a while. And that was with second generation sequencing. That's with Illumina sequencing. With Sanger, genome sequencing was kind of, back in the day, the first genome I think cost several $billion to assemble. So it was very, very expensive. And then Sanger is kind of an expensive technology, if I understand. I've never worked with it, never had a Sanger genome. It was Illumina that brought the costs down. So they're the current sequencing giant. They're worth 50 billion or market cap. They're give or take a bit 10 billion. But they're the ones who really drove it, the costs down, and made clinical sequencing kind of a thing, right? They're the ones who put it on the map, to their credit. And so basically they were comparable to kind of Sanger sequencing. There are some trade-offs, for cost and this, but it wasn't really, it was still, we needed to finish the rest of the genome, and that's where long read kind of came in. And long read sequencing with the two companies, Pacific Biosciences and Oxford Nanopore, and also the optical genome mapping company, Bionanogenomics. And so those three companies and their efforts in cooperation with the National Human Genome Research Institute and a lot of these kind of nonprofit organizations, it was actually kind of in the past 5 years, I would say, that the big leap in genomics has taken place from, kind of the status quo to now everything is complete, telomere to telomere. And we're talking about creating reference genomes that are complete for various populations, and maybe after beyond that, making it standard to get a telomere to telomere assembly. I mean, like it was like it was pretty linear, in what was being accomplished up until 2017. And then you and Ashley published that first time the clinical use of long read sequencing technology. Then suddenly there was a kind of a bump of interest, and then as long read became cheaper and cheaper, just like Illumina became cheaper and cheaper over the years, then suddenly it started being used in kind of research capacities more, and then boom. And now you and Ashley, if you look at his LinkedIn, he's my personal hero, by the way. He's the guy who basically got me to where I am today. He's just an amazing guy. He talks about long read sequencing being ready to hit the mainstream, getting ready to hit the clinic, and the way he did it, it's really fascinating. So nanopore sequencing works very differently than other sequencing technologies. It's basically the DNA is threaded through a pore, right? A protein pore, and there's an electric current. And then, based on the electric current, there's some resistance, and then that determines what base pair it is, because they all have kind of different electrical signatures as they go through the pore, right? And anyway, what they found is that unlike other sequencing systems, that have polymerase as a bottleneck. So Illumina and PacBio, they both use polymerase to kind of go down the genome, and in the case of PacBio, it clips off a phospholinked nucleotide. So it's like a nucleotide that bounces around in this vacuum chamber called a zero mode waveguide, if I'm remembering correctly. But in any event, it clips off the nucleotide, and then it bounces around that, and then that determines whether it's methylated or acetylated, the kinetics of it bouncing, and then the light determines what nucleotide it is. It's an interesting system, but it's all based upon the speed of the polymerase and how fast it goes down the genome and clips off the phospholinked nucleotide, right? They're both polymerase-based systems. Whereas Oxford Nanopore, it's the only thing that is limiting it is kind of computing power. So what you and Ashley did is he created a giant, like, mega array of GPUs, right? And NVIDIA is actually working with Oxford Nanopore. And so he created this giant array, and it just like super processing power. And it's just kind of spat through the genome super fast, and was able to. It didn't sacrifice any quality. It was just fast, right? And so now he's scaling this, and NVIDIA is working on scaling it, and it's actually pretty economical to do it this way. It's pretty amazing. Anyway, did I answer your question, or did I go off on a tangent and lose what I was responding to?
Yes, I think you answered the question. So essentially, this is the first time that we truly have a complete sequence of the human genome, not just 92% of it. And this is very helpful for those patients whose diseases may be influenced by the parts of the genome that weren't sequenced before, that would have been more difficult to sequence using earlier 21st century technology. And I have linked to you and Ashley's Wikipedia page here, and from there one can explore other resources regarding his work. I also want to thank John H. for his generous donation. Thank you very much. Also for your loyal viewership and comments. Now I would like to ask Art Ramon if he has any questions or comments for John.
Like I was saying earlier about my hip issue, this was like in 2018 when I restarted running, and then I had to almost immediately stop after maybe a month or two. I just had this horrid pain in the hips. So I got an orthopedic guy, he x-rays it, and my ball joint had completely worn through the socket. And the only solution he had for me was cortisone shots. And I've heard a lot of bad things about cortisone shots. Like, no, I don't want a cortisone shot. Is there anything else like stem cell treatment? He's like, no, you have to go to France, is what he told me. He actually got pissed off that I didn't want a cortisone shot. And I've heard that it could have the effect of weakening cartilage over time. And I didn't want that. I also didn't want to eliminate the inflammation and the pain and continue wearing out that joint. So what I did was I stopped running to preserve the joint. And then I did some research looking at what foods help the body create more human growth hormone. And I found two was salmon and raspberries. So I integrated that into my diet. I eat lots of salmon and raspberries. I had a TENS unit for my lower back. Previously I had some back issues, and I just put that on my hips, and I just electrified the hell out of my hips to try and stimulate any growth in there. And I've been able to get rid of that pain, and I've slowly rehabbed myself doing walking. So I kind of power walk now, and I haven't had the pain come back. So hopefully I'm preserving that joint so that some future technology like you're sort of bringing can help me out, a few years from now when the insurance, will pay for it. So it's good to hear, the progress that you're experiencing. So
My suggestion to you would be to look into pomegranate extract as a supplement. That's really saved it's just been so instrumental in helping me deal with my back pain before I had this procedure. Hilariously though, just keep in mind, I didn't realize it was a blood thinner. And so I have kind of a gothic, kind of macabre sense of humor. And when I was at the doctor's office, after they had extracted my bone marrow, I had actually gone to the restroom, and I didn't realize that I was trailing blood behind me the entire way. So, I had just left pools of blood all over the doctor's office and all over the bathroom. And, I was worried that it was going to be a no-go for the procedure. But anyway, my point is that it's a blood thinner, so just keep that in mind if you're getting surgery. But it is amazing at helping you deal with back pain and orthopedic type pain. It helps with collagen formation, and it helps just with a lot of inflammation. So just really consider that. It lowers your blood pressure. So if you have blood pressure problems, maybe avoid that. But I don't want this to be medical advice, just a medical suggestion. Medical, ask your doctor about it. How's that?
Now, a while back, I had seen a video on YouTube, and the guy was saying that apple cider vinegar was really good for you because most people are alkaline. But you're saying with your condition that it's an acidic issue. Have you experimented with apple cider vinegar, or what do you know about that?
Well, the disc is actually, so the disc is pretty isolated. Like, it has a different pH than the rest of the bloodstream. So, the thing is, the way I described it to my physician, and he actually said it was a great way to describe it. Having degenerative disc disease, especially when you have that burning pain, it's like having gastroesophageal reflux disease and not being able to give yourself Tums. You're just stuck with a burning disc. And so that's the reason that this bicarbonate was so awesome, because it's the same sort of sensation I'd have when my stomach was just burning with acid, right? I take Tums and I get that relief, right? The same instantaneous relief. That's what I got in my back. I was just in my Instagram post, I was just gasping because it's just I've been dealing with this for 12 years, and there's something called breakthrough pain, and that's like when you take painkillers and it just breaks through that. Even with opioids, I could feel that little nagging back pain. Like it would definitely take the edge off a lot, but that burningness, that it just wouldn't. But then when I was on the table, I was on gabapentin, I was on cannabis, I was on hydrocodone, I was on triazolam, I was on a bunch of things. I was a little bit of clonazepam I snuck in just to increase my benzo dose. But I was on a lot of different things to help with my pain, and so Tylenol. And when they injected that bicarbonate, I felt it through all of that. I felt it. I just felt it kind of seeping in, and it was just like a cool breeze in my back. And that's why I gasped, because it just felt so damn good. And I bet you that's what I really want, that same feeling for all the people out there that I feel very sorry for, that they're just like me, that had that. I want to give them that relief, because man, the world, no one deserves this pain. Doesn't matter how bad of a person you are. I don't think anyone deserves chronic back pain. It's awful.
Yeah, my back pain sort of comes and go, but right now I'm not as concerned about it as I am with the hip. I definitely want to preserve the hip because I just don't want a hip replacement. I think it's just very low tech.
Yeah.
But the first joint that I'm probably going to experiment with this newer form of treatment that comes out eventually that is covered by insurance, probably my knees. It's easier to get to the knees. So that will be the first joint I experiment with.
Yeah. Stem cells aren't that far away. I mean, they've already been injected into knees, joints, all this. People get them all the time. So it's only a matter of time. And getting injected into your hip and all in your joints, everything that's causing you pain, that's going to be probably within the next year or two before that, when that's rolled out. It's gaining a lot of momentum. Stem cells are finally, and I've been following this since, Obama lifted the stem cell ban in 2010, I think it was. Because I was wanting stem cells since in 2010 when I got my degenerative disc disease. It's finally in a position where it's imminently going to launch. So when it launches and it's FDA approved, just go in, get stem celled the hell out of. You're going to feel better very quickly. I guarantee you, it's going to help with pain. I don't know if it's going to regenerate it, because we're still, just like sequencing, they say we're in the first generation of regenerative medicine. So what you can definitely expect is pain relief, and maybe a longer window for that before it gives out completely. But second generation regenerative medicine aims to actually restore structure to what, and so that there's a lot of research on that, and it's getting very, very molecular, very, very granular, like what's going on. And so if you do that, what I suggested with the news, like joint regeneration, or this and that, and the Google News tab, you can stay on top of everything. If everyone that's getting that sort of therapy, everyone that's experimenting with it, that's the best way to keep in the know and who's doing what. And so if you ever get desperate, you'll have a list of names to reach out to, of people that are experts in that very particular area, So that's what I suggest.
All right, thank you.
Yes, thank you, John. And Celeste Castaldo writes that the pain management physicians that she works with regularly use stem cells for knees, hips, the spine, and all joints. So this field of medical application is definitely advancing. Now, John, is it correct that since the bicarbonate injection, you have been able to discontinue using those painkillers that you described?
Well, I actually don't use painkillers that often. I was just using them post surgery, every time, post procedure, I should say. But I really don't need them right now. I haven't needed them for the past 5 days. And it's because I was actually getting sciatica. Was actually the reason that I really wanted to proceed forward with this, is that it felt like a burning sciatica. It felt, and what happens with degenerative disc disease is actually from my understanding, is that a lot of the adjacent, even if there's no like obvious puncture to the disc, there is some acid being kind of released, into the nearby areas around the disc, and this can agitate nerves. It's like your nerves are being burned with acid, right? And that's what happens all around your back, and it just causes this sort of dull pain. And the more acid there is, the more it burns. It goes from ache to burn, and I was just getting sciatic that just burned, and it felt like acid. So that's why I really proceeded with this, and I wanted to stay off painkillers because I didn't want to injure my back without knowing that I injured my back. So I would always just take supplements and things to be very careful, because unlike other people, I actually have problems with musculature, and so I have to be very careful. I have to know when pain is getting worse. So it kind of makes things a little extra hard for me. But um, I like to add before anyone goes out there and does any wild things with stem cells, you should be getting the only types of stem cells that you should be looking into are probably mesenchymal or hematopoietic. I don't know how to pronounce it, but those are those are kind of the two stem types of lineages of stem cells that are kind of approved. If people are making claims about stem cells curing Parkinson's disease or Alzheimer's or all this other stuff, that's snake oil. There's a lot of snake oil out there, and you want to be careful, because there are people that have gotten stem cell therapies, and they've been injected with uh, like pluripotent stem cells, which is very dangerous, and they've gotten like teratomas in their spine, and teratoma is like a growth of like basically like a tumor of like random stuff. It's like it'll be like a blob with like hair and like teeth. It's just like random stuff will grow, like, and so, yeah, you just really want to be careful about stem cells and make sure that you're going to someone who isn't over promising. If they're the type of guy that over promises, they're like, oh yeah, stem cells can do everything, they're amazing, yeah, 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 they're probably going to give you something dangerous. So, my advice for looking for a regenerative medicine specialist is someone who's quite clear about what they offer, and I go to Dr. Shonak Patel. I'm not afraid to say that. I think he's one of the best that I've ever been to. He was actually affiliated with Regenix, the Regenix Clinic, which is one of the first stem cell clinics in the United States after the stem cell ban was lifted. Actually, they were doing stem cells before that in the Cayman Islands, but they've been operating in Colorado and elsewhere for a long, long time. I went to see them, and Dr. Patel started his own practice. And anyway, just be really careful about who you see for stem cells. Be careful about going to Mexico to save on money. Be careful, especially about intravenous stem cells. Don't do that, like what I did. Just get them into the specific tissue that's a problem. Wait until stem cells become more advanced before you do something more risky with them.
Yes, and thank you for that note of caution. I do think it's extremely important to consider what is known and what this technology is not yet capable of. Nobody can cure Alzheimer's disease yet. Billions of dollars of mainstream medical research have been devoted to this, and unfortunately, there has not yet been the kind of breakthrough that would significantly reverse the damage caused by that disease. This is a great tragedy, and a lot more research needs to be dedicated to this goal. But yes, if somebody claims to be able to cure Alzheimer's disease with stem cells, they are essentially trying to deceive credulous patients. And I do think somebody who takes the proactive approach, as John has done, and to educate himself, will also pay attention to multiple sources from well recognized, respected, credentialed medical practitioners as to what is or is not possible, and form a general understanding that would be able to at least get those red flag types of signals to be generated whenever there's a claim that seems outlandish, that seems to be well beyond the reach of contemporary medical science. As our friend John H. points out, if it sounds too good to be true, well, it probably is. And we want to be in a situation several years, several decades from now, when cures do become available for ailments that are currently incurable. But when that happens, you can be sure there will be a lot of published research on this. There will be a lot of media coverage. It's not just going to be one lone owner of a clinic in Mexico claiming that it's possible to do that. So having a good deal of skepticism as well with this type of research, this type of attempt to get answers for one's own condition is very important because we are here advocating a scientific approach. We're advocating an approach that's actually going to be efficacious and not just something that might feel good or that somebody believes in because they want hope, as contrasted with an evidence-based type of approach. So now I am curious if Ben Ballweg has any questions or comments for John.
Hi, John. I don't know too much about you. I was curious to hear more about your interest in rejuvenation specifically, and how you think you can best help rejuvenation progress.
Well, when you talk about rejuvenation, what I really think the best way forward is, and I've said this many times, is that we have to start, rejuvenation, if we're talking in fantasy terms, right? So let's say you make Dungeons and Dragons, you're a cleric, right? Rejuvenation is like the ultimate spell, right? And you can't really cast that spell until you learn kind of the lower level spells and build your way up there. And so the way I see it is that genomics is the bedrock. That's kind of like it's what is going to lead to every major, well, not every, but many of the major advances in longevity, because it'll allow us to interrogate aging like never before. So this is how precision medicine for rare diseases and longevity intersect. It's the same technologies like nanopore sequencing that can look at epigenetic changes and genetic changes in people with genetic diseases. These can also look at genomic instability. That's one of the hallmarks of aging. And so if we're going to look at genomic instability, what are we going to need? We're going to need a complete picture of the genome, right, to know how it's being unstable. If we're missing a piece, we're not getting the full picture. If we're not getting the full picture, then we're not building our models, our AI models on the best data possible, right? And if that's the case, then it's going to come to erroneous conclusions. So it's all about feeding these AI algorithms the best quality data, and that ultimate data is a complete picture of the human genome and also the epigenome that's on top of it. So that will allow us, for example, to we might actually get more than one genome once the costs come down, and not so much to just look at our genome, but to also look at epigenetic markers. So like what we're eating and how that's impacting our health, and and how that's our aging clocks and all of that, and what drugs we're taking, and how exercise, and maybe we do need to do more or less. All of that is enabled through genomics, and that's what I'm really passionate about pushing, is this telomere to telomere assembly of the genome, and making sure that we focus on that and standardizing that and putting resources behind that, getting the federal government to put. There was something called the All of Us campaign, which the goal of which was to sequence 1 million Americans or plus using Illumina technology. Well, I think something like the All of Us campaign, but maybe with a smaller number at first, a smaller cohort, but there should be an All of Us campaign that seeks to create telomere to telomere databases of individuals, right, including their epigenome, everything. And then putting that into kind of a repository for researchers to look at. And the benefit of doing that, not just for rare diseases, is that in the process of buying and paying for these genomes, you're actually giving the genomics companies a revenue stream so that they can innovate, lower the cost of their technologies, and put more things out. And so then those can be used for things, that like longevity with increasing cheapness, And so yeah, I mean, there's a huge intersection between longevity and rejuvenation biotechnology. And again, and I honestly believe, I know Aubrey says it, that you can approach it without fully understanding it. And I think he's right, because on some level, my dad benefited from Pacetin, which is a senolytic. I can talk about that later, but if we really want to master aging, if you really want to master it and have absolute control over it, you need to master genome biology first. It's just the bottom line. It's the soil from which the tree grows. So that would be my suggestion. I mean, it's the soil from which regenerative medicine grows. It's another hallmark of aging, stem cell depletion, right? So genomics would allow us to control what stem cells become, right? The Yamanaka factors can clear all the epigenetic markers. It becomes a pluripotent stem cell. Then what we can do is we can, if you have a genetic disease, you can edit out the genetic disease, and then you can maybe somehow find a way to manipulate the epigenetic markers so that the cell becomes a brain cell or a disc cell or whatever, a skin cell, whatever you want it to become. So the ability to manipulate biology will just make a quantum leap once we have full control over the genome. It just can't be understated. Genomics is the bedrock of the future of everything, and once we get mastery over that, then the sky's the limit.
That sounds good. If I can allow you to, or give you a segue into PathoGene, I don't know if I just looked as, we haven't even talked about that yet. I don't know if you want to go into that aspect of knowing thyself and how important that is.
Sure. PathoGene is actually an infectious disease diagnostics company that was born out of my hackathon. So I was actually diagnosed with Nanopore whole genome sequencing at 30x. And my brother, who's kind of a wunderkind, he math, economics, finance, triple major. He wrote a script. He put the entire exome on Wikipedia, all 20,000 protein encoding genes, and he wrote a script so that it would pull from like PubMed or the NIH. I forgot exactly, but it would update every gene as there's information published about it automatically, and it's still operating to this day. But as more becomes available, it's pretty badass. Anyway, my brother started PathoGene with me and 3 others, including Paul Spiegel, who some of you may know. And what it is it's basically a fully automated metagenomic. Metagenomics is like basically looking at the things beyond the genome, like your microbiome, and or different things that are genomes beyond your genome, and so we're basically developing a metagenomic test that can diagnose all known and even all unknown human infections in 6 to 8 hours for $125, and it's fully automated and cloud based. It's a complex. I can walk you through it in a moment, but it's a one-stop shop for every pathogen and their antimicrobial resistance. And so we'll be able to profile, like what drugs, like, in the case of like things like sepsis, which is what we're really targeting for sepsis, infectious meningitis, infectious pneumonia. In the case of sepsis, the standard of care takes up to 60 hours and has a high false negative rate. It's very hard to culture a lot of pathogens. That's the standard of care. Our device would make that 6 to 8 hours and also provide the antimicrobial resistance, which would allow the provider to prescribe the right antibiotics in a very timely fashion to save someone's life who's got a blood infection. So that's really what we're trying to do. And the way it works is, so we have a robotic liquid handling robot that takes the biofluid from the provider. Once the provider gets it, it's a point of care device. Then the liquid handling robot then puts it through a series of kind of protocols to prepare it for genome sequencing, and that includes host DNA depletion, that means getting rid of human DNA. Cell lysis, that means cracking open the shells of the pathogens. You know, and there's a bunch of other kind of wet labby stuff that goes on, but once all the DNA has been extracted and it's just kind of floating in a solution, right? Then it's loaded into the genome sequencer. The genome sequencer sequences it, and then it uploads it into the cloud. There's cloud-based bioinformatics, which with our partners that do that. Then after the cloud-based bioinformatics detect the pathogens and the antimicrobial resistance genes, then they're able to put together a report for the clinician. And so then they get that between 6 to 8 hours. And the cool thing is that we're making a lot of progress on this. And we just, our dad who passed away from a polymicrobial infection was our first patient, and he was we just ran him through our pipeline, and it detected everything. You know, there's still some optimization that has to be done with regard to kind of host DNA depletion and a few other things, but we've made quantum leaps in the past several weeks, and we're hoping that that we continue to refine this process. And we've also got a lot of interest, a lot of venture capitalists reaching out, and we even got invited to apply to the Military Prototype Advancement Initiative and the Navy Multi-Topic, which are kind of like fundraising platforms for kind of ambitious startups. So we'll have to wait and see. I don't want to overpromise, but there is a lot of. I'm very optimistic about this working. So and I'm very excited to be a part of it. So that's what we're doing there.
Thank you.
Yes, excellent. Thank you, John. And our friend John H. wonders, is the program you described publicly available yet, or is it still under development?
The program is in the MPAI, or you're talking about our device?
Yeah, I think he's wondering about the device, but I will let him clarify in the chat if he has any other thoughts or intentions with that question. But if you could speak to that, I think that would be helpful.
It's not publicly available yet. We are still doing early stage R&D. We have a full-time research and development scientist at our labs in Monrovia, California, and she's got experience with Nanopore. But we're still optimizing it, and it's going to be probably a few years before this technology becomes available. Maybe several even. It depends on the regulatory landscape and how much leeway we're given. Theranos really created a lot of skepticism about emerging medtech, companies, a lot of paranoia and pushback. But we're hopeful that this is going to be the way forward. There's already other companies that are doing this with inferior genome technology. They're bigger than us, but they're using Illumina-based platforms, whereas we're using Nanopore technology, which is the future. So, I mean, we have that patented, so it's kind of in the bag for us. We just gotta keep fleshing it out, and yeah, probably a few years. But once that happens, we might not have to deal with any pandemics ever again, because some of these devices, assuming throughput increases, and I'm the guy who kind of envisions the future here, but assuming throughput increases on Nanopore technology, which it very well will, it might be able to be installed at things like airports and bus stations, things like that, so that people would be able to get tested before getting on a public transit, and infecting people. I mean, that's far down the line, but this is kind of the end of the road for pandemics, as I see it. This sort of superior surveillance that we're providing with this technology, and the automated laboratory tech work, which is what the robotics does. It's just an automated lab tech. It's really nothing fancy. It's just it performs the same jobs as a lab technician.
Mm-hmm. Yes, thank you, John. And John H. made a clarification post. He was referring to the gene updating program that your brother developed. Does that help pinpoint what he's asking about? I believe you're on mute.
Yeah, so yeah, it's still updating. My brother developed it, and you're asking, is it still updating to this day, or is it public? Oh yeah, it's public. It's all on Wikipedia. Here, look up list. I'll put it in the chat. And
Yes, we will post this as soon as John makes it available. And also, one aspect to think about as our next question will be, what do you think of the current role of the FDA? Because you mentioned the increased regulatory scrutiny since the Theranos debacle. On the other hand, the FDA has been quite an obstacle to the rapid approval and deployment of life-saving treatments, including certain treatments and preventative measures that have been vital in the ongoing crisis that I'm not going to mention for algorithmic reasons, but I think we know what happened with various FDA delays in this regard. So what do you think about the FDA's current role in terms of either hindering or helping these treatments become available to patients and available in a safe and effective manner? Do you think the FDA is on net a good influence or a deleterious influence?
That's a great question. I'll answer this question. If you don't mind, I'll just take a quick break after I answer this one. But what I wanted to say is that there is hope for regulatory innovation. So as part of Biden's budget, the Health Advanced Research Projects Agency, which is modeled after DARPA, the Defense Advanced Research Projects Agency, was officially established. And their goal is basically to take bold and rapid steps with medicine, and they can sidestep red tape. Anyway, one of their missions is actually regulatory innovation at the FDA, so that they can actually get these medicines to market in a faster way. So, and by the way, that list of protein encoding genes, it's multiple pages, but that's what basically the script my brother wrote basically kind of updates. But anyway, I honestly believe that HARPA, or ARPA-H as it's called, I really think they should have called it HARPA. But ARPA-H is really going to, I think, move the needle forward as far as regulatory innovation at the FDA, because it's recognized that it's very much needed, especially with all these complex new biotechnologies that even some of the highest echelons at the NIH are having trouble keeping track of, because things are getting so specialized and so siloed that just sometimes you really just you kind of need a dedicated body to kind of work on regulatory innovation. And I think that ARPA-H will be well equipped to do that, because it'll be kind of there'll be experts at ARPA-H, that are full-time employed, and then people that are working with ARPA-H from like universities and stuff that have really good ideas. And I feel like it's gonna make big changes in our healthcare landscape. ARPA-H is probably the biggest regulatory thing in terms of health that this year. I think it's one of the, and it might actually be one of the biggest of this decade, because as you well know, the DARPA is what led to the creation of the internet, GPS. A lot of the foundational technologies we all enjoy today were created by DARPA, which has a minuscule shoestring budget, but what they do is big moonshot programs, big, ambitious, bold things. And so the thing that's really encouraging is that they might focus on aging. That might be something that they eventually focus on, because of course, as Aubrey says, it's an uphill battle to treat diseases if you're, as you get older. So obviously ARPA-H, that's not beyond their purview. And they are gonna change things up. ARPA-H is gonna be an amazing organization. I just know it. So that's my answer to that.
Yes, thank you very much, John. And the other John wants me to thank you for your answer as well. And John is going to be back in a few minutes, but in the meantime, we have some interesting comments along these lines. So Mike Lazine writes, the FDA should be canceled and replaced with our version of it. And he's correct that we do have a proposal in our platform. This is section 118 of the US Transhumanist Party platform, which supports abolishing the FDA and replacing it with a radical life extension administration. This was adopted by a vote of our members during March 25th through the 28th of 2020. So we were deliberating various policy responses to this ongoing public health crisis that the world is mired in and has been mired in for the past 2 years. And our platform reads as follows: given the extreme delays, bottlenecks, and expenses created by the mandatory approval process of the Food and Drug Administration, the United States Transhumanist Party supports abolishing the FDA and replacing it with a Radical Life Extension Administration, or RLEA, whose mandate would be to prioritize the rapid development of potential disease cures, treatments, and a word for a very important medical therapy that I will not mention for algorithmic reasons, including any possible cures or that particular type of therapy for a particular disease that I will not mention for algorithmic reasons, as well as treatments to mitigate and reverse the diseases of biological aging, which is the major risk factor for this ongoing disease that I will not mention. The RLEA would allow the marketing and collection of patient data on any particular cure, treatment, or very important type of treatment that I will not mention for algorithmic reasons, which has passed affordable safety testing at a reasonably acceptable threshold. So you can read the text of that platform section to know what words I chose not to mention. However, we are strongly supportive of medical innovation, and a Radical Life Extension Administration would facilitate that. So this is not abolishing any federal agency oversight or testing or reviews for safety or even efficacy, but this would prevent the FDA bottlenecks that have unfortunately cost many hundreds of thousands of lives in the United States, to say the very least. And then Mike Lazine responds to thank me. He couldn't remember the name of the Radical Life Extension Administration, but there it is. And we also had an interesting commentary from our friend Sergei Gubkin, and he writes that if a claim, any given claim from somebody who purports to offer a cure, is not through valid scientific research and not supported by any known reputable scientists, it is probably like a perpetual motion machine, so pseudoscience or something that is not possible using the laws of physics. And common sense, while it's not the standard in terms of making scientific conclusions, is a good guide on whom to trust. That's Sergei's view on it. So we, as intelligent laypersons, while we may not be medical experts ourselves, so we may not be able to definitively say, oh, this particular treatment will work or it won't work, we can have a certain ability to discern pseudoscience. We can have a certain ability to discern approaches that probably are not worth pursuing. Like if somebody says that if you touch a magic rock, then your back pain will go away, or you will be cured of Alzheimer's disease. Clearly, we can figure out that this person is probably mistaken or is trying to sell us something that will not be efficacious. But John, welcome back. And one other question that I wanted to ask you stems from another comment that Sergei Gubkin made with regard to the prospects for genetic sequencing and cures for rare diseases. He thinks we may have more rare diseases on our hands because of the various incidents in Eastern Europe with radiation leakage, say from the ill-fated occupation of Chernobyl by the Russian military, where they did actually subject themselves to a lot of radiation exposure, and they were negligent with the safety controls. So with the human genome having been completely sequenced now, do you foresee the ability to rapidly test people who may have been exposed to radiation for any genetic anomalies that that has resulted in?
Yeah, I do actually. And the way I foresee things is that, they talk about genomic instability, so you can have mutations, in one part of your body, and basically, what you could do is you could look for a genomic instability by doing multiple genomes from multiple tissues, right? I mean, if the future is basically being able to do that from a ton of different tissues at once to evaluate how it's doing, what your cancer risk is, all this and that. And I think that technology, we're well on our way there. Advances in biotechnology go by Carlson's curve, not Moore's law. So the advances are exponential, and what we're seeing now is finally that leap up. That leap that we've been waiting for so long for. The majority of the advances in medicine, if I recall, have been in the past, in human history, have been in the past 100 years. Like the vast majority have been in, and then I would say within that 100 years, it's like disproportionately within the last probably 2 decades that we've made, the lion's share of strides for everything, So, and it's getting crazier and crazier, these jumps. So I think that as we master genomics and we're able to bring the costs down, and the costs coming down is a huge deal, because that's how many, the cost determines like something. So when you get your genome sequence, there's something called coverage. So you usually see a number by a genome, like 30x, 40x, 50x, and so that means like the number of times your genome's been sequenced. So then what they do is they sequence it 50 times, and they put it in a stats program. And here's like the genome here, here's the genome here, here's the genome here. This is what base was found here. This is what base was here, 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 here. So like 47 out of 50 said G. 3 out of 50 said T. It's probably a G if 47 out of, so that's kind of like how they do it to make sure that they base call correctly, right? So like, coverage raises the cost a lot, but just imagine if costs were really negligible. It costs almost nothing to sequence your genome, and you could get really high coverage, high enough to get a telomere to telomere assembly, and in fact, high enough to do it from multiple tissues at once. You could do so much with that. As I said, it's not just stem cells, but you could study how radiation, and possibly even semi-real time, because the nanopore technology is making huge strides, and right now it goes through an electrical current. But what the 4th generation technology of genome sequencing technology is going to provide is actually, I think, speed of like unprecedented scale, and it's going to be using nanopores. But I can tell you, this is what I honestly think it's going to be. It's going to use spectroscopy in some capacity. So it's going to be sequencers are going to be optical, because the reason for that is because, you put something through the electrical pore. I heard someone in a longevity discussion talked with me about this. It can change it can affect the epigenetic reading of things, because it's going through something that's going to disturb it, right? So you want it to be read by something that doesn't disturb anything in the genome, right? Doesn't change anything. And so basically it's going to be nanopore sequencing, but instead of an electrical current, it's going to be some sort of optical device. And so there are already companies like, I think, Harmonica that are working on that. And that's going to be like 4th generation sequencing. It's going to be extremely fast, extremely cheap, and we'll be able to do all sorts of cool studies with it, including studies on radiation and possibly how to stop radiation poisoning, maybe come up with some therapies for it, and be a lot possible when genome sequencing is accurate and scalable.
Mm-hmm. Excellent. Thank you, John. And along these lines, Zach Richardson, our Director of Publication, wonders what sequencing company or companies you would advocate as providing the greatest value and which ones would produce the most complete results.
If you're looking to be economical, well, unfortunately, I hate to tell you this, but third generation sequencing is going to be out-of-pocket affair. So, so the two sequencing providers out there are Pacific Biosciences. They're a single molecule real-time sequencing platform. The name of their device is a Sequel 2E, Sequel 2, and then or Sequel 2E is their updated one. And then Oxford Nanopore. Those are the two available sequencers. Harmonica is like us. They're prototyping, so they're not available for sequencing. So in my opinion, Oxford Nanopore is the best platform because it is cheaper than PacBio. So last time I got quoted for 30x, it was like 7,000. This is probably 7-9 months ago. Costs have probably changed. They're probably 2/3 of this, or maybe even a half of this by now. But Oxford Nanopore for 30x coverage for my genome was about 7K, and PacBio was about 10.5K. So for about 25-30x. So and Oxford Nanopore has made some major advances in its nucleotide level accuracy. So basically, it's almost as accurate. It's pretty much as accurate as Illumina now. Very accurate. So if you want to get the best quality genome you can possibly get, I would get maybe 30-40x Illumina, and then if you have a short read genome, you can combine that actually with something. We can talk about that, but there are algorithms like WenGAN-D, WenGAN-D. I'll post that in the chat. But then you want to get an optical. The two things basically that are essential is Oxford Nanopore at 30-40x coverage and an optical genome map from Bionanogenomics. And they are not genome sequencing; they are an optical map. But what they do is basically provide you with a scaffold against which to assemble your genome. So here's the thing. Here's why it's really important. Sorry, kind of multitasking here as I. That's an article I can share. So currently the way that we do things for genomics is we have something called a reference genome, right? And so when someone gets their genome sequenced, your genome is assembled against someone else's genome. Now, you can probably guess this leads to some problems, right? So let's say you have a few repeats of a certain gene, right? And the reference genome doesn't have that. Well, you may end up losing that information because you're basically trying to fit your genome into the mold of someone else's. What I am proposing that you do is a de novo genome assembly. And what that means is from scratch. So instead of using a reference genome, you're building your own genome from scratch. And so the optical genome map is like a big mega scaffold. It's like a zoomed out picture of the shape and the length and everything of your genome. And then you get the sequencing, and then you can align that to the optical map. Instead of the reference genome, you can align it to an optical map, which is based on your DNA. And then if you happen to have like a Illumina genome or one of the Chinese ones, MGI, BGI genome, you can use that to further polish, the genome that you have. There are algorithms that combine all of these together, and then we'll give you a master genome set. And that's how the telomere to telomere assembly of a human genome was done. Is with multiple technologies that all kind of complemented each other. And but as time has gone on, I think it's become possible to do it just with Nanopore and an optical genome map. So theoretically, if you get high enough coverage, if you really put some money into it, you might be able to get close. If not, I don't know how much it costs. Probably a lot, but to get a full. I think they did. I think they were like at 150x or something like that to get the to get the reference. I mean, to get that telomere assembly. It was really, really high. I forgot what it was. But you can get better than almost everyone else on the planet if you get like 40x, 50x, and BioNanomap. You pay about $10,000, probably maybe 11,000. But if you had a genetic condition that you wanted to get figured out, I can tell you this: it's the sexiest data set you can possibly. That's why I got 200 people from around the world to come look at my genome. It's because I had Oxford Nanopore, which is not common for human beings at the time in 2019, and even now it's not common. And PacBio, and I had all this other. I had a metabolome, I had a proteome, I had all these ohms, and then I was just right there. Do whatever you want with bioinformatics. People came and they loved digging through it. They had the time of their lives. It was fun for them to use this data. So if you do pay out of pocket for it, I don't think it would be too hard for you to find someone who wants to dig through it. But you might want to tell someone that you're doing it before you get this data, because if it takes you a few months to find someone, costs may come down, and you may end up saving money. You know what I'm saying? So I would say get your ducks in a row, find someone to do analysis if you're not doing it yourself on the data, and then get the data, and then have them do analysis, and then you might find some really cool insights, and it'll probably cost you south of 10K. And that's what I suggest.
Yes, that's fascinating, especially considering that the Human Genome Project cost about $2.7 billion in 1991 dollars, which would be about $5 billion today. And yet, John, you said somebody could have a much more complete personal genome sequencing done for essentially $10,000, and the cost is coming down still. So hopefully this will be affordable, not just for people of middle class or somewhat affluent means, but even ordinary working class people in the coming years, and certainly in the coming decades. Now, Zach also wonders if you get individual reports on certain genes from various research companies or researchers who have looked at your genome or other patients' genomes that you're aware of. How does that process work?
Well, there's no real standard, I have to say. You could probably get one, possibly, if you asked for one. My genome was discovered with QIAGEN's. That's I'm not sure where it's a European company, I believe, but it's QIAGEN, QIAGEN's bioinformatic pipeline. So they're the ones that identified my compound heterozygous frameshift mutation in the TNXB gene. And so they didn't give me necessarily a report. They just they had like a list of genes and like probabilities of what's causative and stuff. Everyone had a different kind of thing. And since it was a research setting, there was no real standard. But you can, if you pay money, you can get that from someone probably. There's something called the Science Exchange. That's probably where you're going to get. You're not going to be able to get this sort of service anywhere else. The Science Exchange is kind of like eBay. It's like a mercenary site for wet lab services. So, you want a metabolome, you want a proteome, you want a super cutting edge, super technology, this, that. It's on the Science Exchange. Some providers, that's how they make extra cash, right? They're like, oh, I'll do this for you, and they have a reputation just like on eBay, right? And you ask for a quote. You say, this is what I want. This is the specifications of my project. How much what's your deal? And you can ask 5 people at once. And so, yeah, the Science Exchange is kind of like, if you cannot get the testing that you want, you can get it through the Science Exchange in a research capacity. But that bioinformatic part, you might be able to specify that on the Science Exchange once you have the testing, or maybe one before you have the testing. You say, I'm going to be getting this testing. I see you offer bioinformatics services on long read data. How much would that cost? What could you do for me? And you work it out beforehand. So if you have extra money on your hands, which, I have never used the Science Exchange, services, but I've definitely interacted with people on there for organizations, like Research to the People, to help them find providers for other patients. Yeah, you can find pretty much anything on there, provided you have some money to pay. And if you have about 10, 12K, you could get basically the futuristic genome and a futuristic analysis by some of the smartest people in the world. Something that won't be available probably for another 1 or 2 years. You'd be able to get that now. So it's something to look into. It's unfortunately, nanopore sequencing is not FDA approved yet, and that's what you and Ashley, the guy I've talked about, is basically pushing. He's trying to push it through. He's trying to push it across the finish line. He's saying, look at it. Look at you and Ashley's LinkedIn page. He talks about this, his latest post or his semi-latest post. He talks about how he did a bunch of rare disease patients, and he diagnosed them. Genome sequencing used to take, when I had it done, it took 3 months to sequence a genome and analyze it. It took a long damn time, and then there were delays, and it was like, 4 months, 5 months. Finally, we have it done. This guy did it from sequencing to diagnosis on several patients, an average of 10 to 12 hours. 10 to 12 hours. And he raised the diagnostic rate from 30% to 42%. So, I mean, and he says that it's ready to be, rolled out. 10K, insurance could cover that maybe once a lifetime at this point, once in a blue moon. It's kind of like the way that an MRI used to be, expensive as hell. You get an MRI once in a while. I mean, I think that this is it's getting to the point where it's going to be covered soon. So you might just wait. You might save a lot of money.
And I've linked to the article that you mentioned, John. I accessed it through you and Ashley's LinkedIn profile. But yes, this article headline states clinical grade long read genome sequencing is here. So thank you for pointing our viewers to it. Now, I wonder if Jason Geringer has any questions or comments for John.
Well, this is all pretty interesting. I actually have spinal stenosis, and so, I've been dealing with chronic back pain for about 10, 12 years now. I try to look at the bright side. I mean, if I hadn't had that happen, I wouldn't be here right now talking to you, probably. It's what got me online, and which, got me doing, it changed my whole, it was like COVID for me personally. It happened before COVID. Oh, I was supposed to say that. the algorithmic, yeah. That's that thing that shall not be mentioned, that, Anyway, so I'll be honest with you, though, at a certain point, I kind of didn't want to have hope, because then, sometimes it's just easier to just not think about it and just that you're going to be in pain forever, but this is very interesting. I'm wondering if this bicarbonate injection would possibly help for me, because I'm like Art. I didn't like the idea of cortisone shots. I went through them, and I jumped through all the hoops that the doctors wanted me to, and it's still never done anything. And it actually was just pretty painful to go through these procedures for no result, so I don't really have any particular questions. Maybe where do you think I should maybe start trying to research to see if this bicarbonate would help me or something? I'm wondering.
I just want to point to this paper here. I mean, it's kind of an obscure paper, but I'm going to highlight something. Here's the link, and here's the conclusion. So this is an interesting conclusion. This is exactly what I experienced. So conclusion: acid-base neutralization is instantaneous, which may be the reason for rapid reduction of discogenic pain from lactic acid burn. So my question to you would be, do you ever feel kind of a burning sensation at all? Do you feel like your discs are kind of like hot, kind of like there's kind of a corrosion going on inside them? Would you say it's kind of like,
I
yeah,
would say, yeah, probably.
because
Yeah.
most degenerated discs are acidic, and that actually, as I mentioned earlier, the disc, even though it's closed, it gets so acidic it starts kind of spewing acid. It spews acid nearby, and that's where the pain comes from. And you're basically being burned alive from acid, right? You're being burned from acid constantly, and that's basically it's screwing up your mood. I'm telling you, like when I got my mood has been amazing the past few days. I feel like on top of the world, because I feel like I'm taller. I feel like when I was a degenerative disease, I felt like I was shrinking, getting like weaker and older and more frail, and like I was gonna die. Like it's just this whole
Yeah.
cascade of mental and so I absolutely think that bicarbonate, if you have that sensation, especially the burning, that bicarbonate would provide you instantaneous relief, because almost all degenerated discs, there's so many studies. I can link you guys later, but lactic acid is now a biomarker for back pain. It's actually a biomarker for back pain. They did studies with MRIs and functional pain scores, and they did some sort of thing where they were able to kind of label the acidity level and self-reported pain scores, and people that had lower pH reported higher pain. And then there was I think there was a study like that, and then there was another study that stated that that determined that lactic acid was a biomarker for disc. There's a lot, and even in this paper here, they point out that it's causative for back pain. So I mean, again, when discs degenerate, they don't get more basic. The trend is acidity until you need surgery, and until the disc basically just pops, and then there's you need a spinal replacement, disc replacement or something, or a spinal fusion or something, so the bicarbonate just gets rid of that sort of burning pain. And yes, it may get more acidic until it's regenerated, and there's some sort of homeostatic mechanism to cycle bicarbonate, which is what gets interrupted in your disc. When you get degenerative disc disease, the cells that basically keep it from becoming acidic, right? There's acid that gets produced as a result of metabolism inside the disc, right? There's some sort of metabolism that goes on, but then there's also a thing to offset that metabolic waste, that lactate, that it's bicarbonate cycling that helps kind of keep that, it buffers the acid so that your disc stays healthy and functional, and that the pH doesn't destroy the extracellular matrix, which is like the pillow of the disc. As lactic acid increases, it just keeps breaking that down, and then disc keeps getting shorter and shorter, and the cushion keeps getting weaker and weaker, and then more and more acid builds up inside the disc, and there's more and more acid inside the smaller area, and then it starts spewing out acid in all directions and causing your nerves to be irritated constantly and ruining your mood. And so the bicarbonate increases the volume of the disc, so it gets a little bit up, and it also lowers the burning pain. And so I do think that it's something that to look into. So stay in contact with me, see how I'm doing, maybe in a few weeks, a few months, and if I'm indeed out of pain for a few months, maybe even a year, it's something. It depends on how long you want to wait, but I could possibly put you in touch with my clinician, Dr. Shonik Patel, and say that you'd be interested in trying possibly a bicarbonate and antibiotic without the stem cells, because you don't have to pay. Stem cells are what jack up the price to several $1,000s, but you'd sign a research waiver saying that a liability waiver saying that you accept and acknowledge the risks. You talk to Dr. Patel and ask him any questions about. You probably want to ask him about discitis, which is probably the only risk and only complication that you could get from this. But I don't think that it's very likely, because P. acnes, which is the bacteria that causes disc pain, it's one of the bacteria implicated in that, achieves optimum biomass at pH of 6, which is 10 times more acidic than 7, So you're moving it away from 6 to 7, it's not going to thrive as much. So the risk of discitis is probably kind of small, because P. acnes thrives within 4.5 to 8, right? So it tends to prefer slightly more acidic environments. Even though it can do okay in basic, it does better in acidic. So anyway, my point is that Dr. Patel is an ace doctor. He's not full of crap. He's very, very honest. He worked with Regenix. He has excellent pedigree. He's known as one of the top 5 specialists in the country. And I agree with that. He deserves that. He won't steer you wrong. So anyway, keep in contact with me. Anyone who's interested also
I
in
will.
therapy. Yeah.
You know, at this point, I had just kind of given up on it, really. And, you know, I know it's pretty sad when you reach a point where you just are, you know, accepting that you will be in pain forever. But, you know, so
No,
yeah, I'd be willing to try some stuff. You know,
check
I'll keep.
out my Instagram of me getting that injection. I'm like gasping in relief. People thought I was acting, on my Facebook. They thought I was just being, because I actually put a camera, or during the procedure, I recorded the whole thing. I'm just crazy like that. I always do stuff like that. But I took a clip where I was just kind of gasping in relief, and they thought, some people thought I was just doing it, for show. But again, I was genuine relief. I was in pain for 12 years, and I was on all these painkillers, and I felt that bicarbonate going into my disc and just getting rid of that acid. I felt it through the hydrocodone, through the gabapentin, through the cannabis, through the Tylenol, through the triazolam, the clonazepam, everything. I felt it through all of that. I felt the relief, and I was just gasping. And to the rest of the day, I was just giddy, with pain relief. And I still feel it. It's fantastic relief. So anyway.
Yeah, I don't know if you guys will still like me. I'll probably turn all bubbly or something. But back to you, Gennady.
Yes, thank you, John. So we have about 3 minutes left in our virtual Enlightenment Salon today. And John, I'm wondering if you could quickly describe the fisetin experiment that you performed with your father, and after that, offer any closing remarks that you might have.
Sure. So before my father passed away, he was in a care home. He had a stroke, and he was basically in a vegetative, basically catatonic state. So, his face was unable to move. He couldn't move his hands. He had to be fed. They thought he was going to die imminently. And so I did some research on fisetin, and I saw that it crossed the blood-brain barrier. And this is not medical advice, by the way. This is an anecdote. Anyway, I designed a cocktail for him with fisetin and omega-3s and all that. And he went from being unable to move anything in his face to being able to walk, to being able to feed himself, being able to speak a little bit. He's making progress on walking further every day with the physical therapist, saying a few words, making eye contact, nodding, interacting with us, when before he was just like completely unresponsive. So fisetin is a very amazing compound. It's from strawberries, but it's amazing. We gave him the Life Extension brand, and my sister and I. And I just can't tell you how amazing senolytics are. They are amazing. So yeah, there is real progress being made. And as for last advice, I just can't emphasize enough. Those of you who really want to stay on top of the news, for medicine and everything, take advantage of the Google News tab. Type in genomics, type in degenerative disc disease, and then type in news. Type in degenerative disc disease treatment. Type in longevity. Type in reversing aging news. No one uses it that I know. I mean, very few people. But I'm telling you, I found you and Ashley's article that way. I found some of the most interesting articles I've ever found just by using that simple news tab. And it can change your life, especially if you're looking at news for something that's relevant to your personal health. You might find something right there on a Tuesday when you weren't expecting it that just shatters your whole world, and not shatters, but makes your whole world something good to it. Anyway, that's my advice.
Yes, thank you very much, John. And you have shared a lot of invaluable information today for people who seek to take charge of their own health and perhaps obtain some relief from conditions that have been troubling them for a long time. And you are certainly a model of that kind of success, of what can be achieved, and you continue to do good work on behalf of so many rare disease patients throughout the world, with your advocacy, with your research, with your company, PathoGene Incorporated. So we wish you all the best. And this is exactly the kind of conversation that we seek to foster here at the Virtual Enlightenment Salons, giving people knowledge at the cutting edge of multiple disciplines in a practical way that they could apply for self-improvement and for bettering the world. So it was a great honor to have you here with us today. Thank you to our U.S. Transhumanist Party officers, both in our video stream and in the chat. Thank you to all of our audience members, our loyal viewers. And until next time, every Sunday at 1 p.m. Pacific time, 4 p.m. Eastern time, live long and prosper.